Okay, so I think the first one was the 4 mark question, which I hope was relatively okay. Tamara, do you get an answer for the question 1, where the chemistry paper?
Yeah, but I don't think it's right.
Okay, or shout it anyway.
7.47 times 10 to the 10.
Okay, Sean, what did you get?
Also that.
Yeah, you're right.
Okay.
Okay, so I won't go into detail how to do it. It's but generally it follows a similar system to what most of these questions are. It's okay, everything's okay. Take away the options that are not okay.
Yeah.
Is that hopefully you did it that way? So I think it's 13 factorial arranged 2 factorial ways is the subtraction. I don't know what.
Yeah.
Is
I hate how big these answers are.
Yeah, that's why it's so hard to know if you're right or wrong. Yeah. So it is 747 by 10 to the 10. Okay, so you have that one. Perhaps the 6 markers are that much. They're just horrible. Not horrible. They're just you have to just make sure you've thought of everything. Interested by your answer to these, Sean? What's your answer to question 2?
I got 181. Wait, there's 3 significant figures, or should I say all of them?
No, you're wrong already.
Okay.
Tamara, what answer did you get?
I didn't know how to do it.
Yeah, it follows a similar process, but it is definitely more difficult. So there are 11 players on a football team. They're asked to line up in a straight line. Okay, so 11 players. 3 players, let's call them A, B, and C, because Adam, Brad, Chris refuse to stand next to each other. So there's these 3, and then there's 8 more.
Yeah.
5, 6, 7, 8. Okay. Right. There's no restriction on the order which the other team members position themselves. Just these 3 members refuse to stand next to each other in any order. So 2 of them can't stand next to each other as well. You know, B and C can't stand beside each other.
Yeah.
Okay, so that's the way. So I did this in a similar way. So I started off with, okay, no restrictions. Off you go. 11 factorial would be no restrictions. So hopefully we're okay with that. Similar to the last question. Then I'm going to look at where, okay, 2 of them are beside each other. So let's say Brad and Chris are beside each other. And then what's our go for that? And then I'm going to say we're all 3 of them. So let's do the 2 of them beside each other first. That's the first thing I'm going to subtract. And it's going to be, well, the other 8 are just going to be any old way. Out of the 3 of them, we're going to select 2 of them to be together. Those 2 can be arranged if it's B and C, B, C, or C, B. So they can be arranged 2 factorial ways, or just 2 ways. Okay? Now, this also must be multiplied. So you understand that if this and this happens, it's multiplying.
Yeah.
And these then, so there's BC is a pair, and A is like a separate dude. And every time this happens, how many slots can they fit into between these 8? I think there's 9 slots between them. You know, 1 at the end here and so on. Between the 8 people. 9, and you choose 2 positions out of those 9. But let's say you pick this one and this one as your 2 positions. That can be both A and BC, and it can be BC and A. So that's also 2 factorial choices, or 2 choices. You can go either option.
Oh, that's a lot of stuff going on.
I know. And that is just if, so basically this bit is 2 together. Now 3 together is actually easier, but 2 together is tricky. You got to think of absolutely everything, because these 2 can be arranged 2 different ways, and then these are like A and BC are 2 different ways, 2 different things as well. So they can be arranged this way and the other way.
Yeah. Okay. Wait. Can we look at just the first part of that again? So,
Yes.
there's 8 factorial. That makes sense because there's only 8 of them left
Yes.
that you're arranging on their own. And then we're doing 3.
Yeah.
Is that
so
3 choose 2?
Yeah. 3 choose 2. We're picking 2 out of these 3 to be stuck together.
Oh wait, so wouldn't that just be the same? And then you're multiplying by 2 factorial. Wouldn't that just be the same thing as doing 3p2?
It might give
Which
the same.
is-
Yeah, it would give.
Okay, yeah. So
Yeah.
so it could just be 3p2, and that would also work.
Yes, that should work there. And
And then you multiply by.
Then I multiply, and then so that's just selecting these, which one goes in pairs,
Yeah.
and what's the pair. So this one can be A, and this one can be CB as well.
Yeah.
Those does matter. Yeah. Okay, and that's the 2 factorial bit.
Okay.
In this way.
Yeah.
Every time you make this decision, we must do it 2 factorial times.
Yep.
Then, so take these as just 2 entities, not 3. They must fit somewhere in these 9 slots in between the 8 players. And the 9 slots can be filled in any 2 ways. Of course, if it's not filled, these players will just be beside each other, and that's okay. But these 2 can't be beside each other, so they have to fit in one of the 9.
Yeah. Okay. So there's 9. There's 9 slots, and then.
Yeah.
And then you're filling them up with 2. Yeah. Okay. So that's also the same thing as 9p.
Yes. And then you do 2 different ways to make it. Order does matter, so P. Yeah.
Okay.
So that's subtracting all that, and that's only the 2. Are you okay with that, Tamara? I know it's rather confusing, but there's a couple of examples of these questions, so we'll do a few of them. So hopefully that makes sense, even if it's not. It is logical, but the problem is you have to think of all the logical steps. Now we must do subtract all the times that the 3 of them are together. So the same thing happens. These 8 dudes will be any old way. Sorry, the 8 dots will be any old way. This time, now this is a rather needless step, but we'll do it. And 3 choose 3, just to distinguish almost. And then they will be in, 6 ways, won't they? Or 3 factorial ways, because it could be ABC, ACB, CAB, and so on.
Yeah.
Now that's going to be multiplied by how many times they're going to. Now I'm going to write this a bit, not stupidly, but a bit long-handed. They can be fit in 9 different slots as well. Choose 1. There only is one way they can fit in the 9 different slots. And not technically, I will add the 1 factorial, just to say that that's the only way they can be arranged. Same as 2 factorial. That's totally unnecessary, but you could put that. But it's 9, or just multiply by 9. So this one's perhaps a bit more logical. If you're writing it out, you wouldn't write, perhaps you wouldn't write 3 choose 3 in 3 factorial ways. You could have just, 3 factorial. You could just, it's going to be 6 different ways for these dudes. And they could fit in 9 different slots. So. Now, if you do all that out, you get about 20 million. 20 million, 321, 280. Yeah. Okay.
Okay.
Right. Let's do. Perhaps we'll do the ones with the question 3 last, because I think the other 2 questions are very similar to this one, more similar to this one, the barcode one.
Yeah, the barcode one it's basically the same thing, isn't it?
Yeah.
Except there's 4 of them and 3 instead of, yeah.
Okay, well, let's, what is your answer to the barcode one?
Wrong. 7.57 times 10 to the 10.
It's close.
But it doesn't matter if it's close.
Yeah, it's close, but that's very far away from the answer. Tamara, did you get the same thing for the question 4? What did you get for question 4? Or did you?
I was, yeah, I just did not know.
Okay. Yeah. So it's very similar operation. So we're going to start. So it has 4 letters of code, question 4, and
And 10 digits.
Oh, you do computer science, John. This should be right up your street.
It would be if computer science had that much math in it.
Oh, that's true. Yeah, that's why they probably do math and computer science. All right. So total 14 factorial. 4 and 10. If there's no restrictions, 14 factorial different ways they could be arranged.
Yep.
Okay.
And then with the next bit, you would have minus, and then there'd be a 10 factorial because the 10 digits can be arranged however you want, right?
Yes. So we'll start off. Yeah, you're going to do it the same way as we did the last time. You're going to pick. So what's the restrictions? No 3 letters may be written, and there's no just 3 letters.
So the first one we'll do is 3 letters together. Then the next one would be 4 letters together, right?
Yeah. So we'll subtract 3 letters, and then we'll subtract 4 letters. Yeah, that's exactly what we do. So the 3 letters, if you just want to choose 3 out of the 4, or choose 3, same as we did the last way, they can be then arranged. So if you pick BCD, they can be CBD and DBC. So that's going to be your 6 ways, or 3 factorial ways. And the same thing, you're going to fit them in how many slots. So now yeah, but now that A, and let's say you've chosen BCD as there's 2, and how many slots? There's 1, 2. In between each one, there's going to be 11, isn't there?
Yeah.
So there's 11 slots, and you're going to fit the 2 of them in.
Yeah.
And that can be done either way. So A can be here, and
times 2 factorial. Yeah.
And B and the other way. Okay, and then the 4 letters would start with 10 factorial as well, because then the numbers don't matter. And then it'd be the same thing. You could do 4 choose 4 times 4 factorial, because the 4 letters can be in any order. So I'll write 4 choose 4 times 4 factorial, and they can be fit in the 11 slots times 11. And
yeah.
Is that what you did?
No, that's what I've just been writing down now.
Okay, so and that would give 7.66 by 10 to the 10.
Okay, it makes sense now. I just need to remember to look at all the different.
Yeah. You need to take into, and that is, yeah. So some people, yeah, it should make sense, but a lot of people forget this factorial, the 2 and the 3 factorial, that they can be arranged in different ways. Once they're in this position, they just take this as an entity in itself, that it's unchangeable. But they can be in all 3 different, or 6 different ways, these 3 together. So that's question.
Before, I also wasn't thinking of it as like slotting them into different things, because I was trying to figure out, okay, it can be arranged 3, but then how do I do it when it's the 4? Because I was just thinking of having them all together and arranging them as a whole set, so I wouldn't be able to differentiate between the 3 together and the 4 together. But then slotting them into different things takes care of that problem by itself.
Yeah,
that makes sense. So slots are good.
Slots are good, yeah. In these kind of code problems, yeah. Okay, Tamara, you're quiet, but I presume that's okay. It makes sense, kinda.
Kinda, yeah.
Okay. Well, let's talk about let's do the last one first, and then go back to that question 3, which was the card game. Question 5 is the desks. Mara, did you get this far, or no?
Question 5?
Yeah.
I got question 5.
Okay, what's your answer? So part A?
Part A is just 10 factorial.
Yeah.
So
whatever that is, yeah. 10B then? Or 5B?
5 factorial times 2. No? Yes?
No.
No? Darn it.
Sean?
I also did that.
Oh. All right. Not what I got. Okay, I could be wrong. So the dudes, two of the students we noticed talk to each other. Find number of ways that they may arrange so that one sits directly behind the other. All right. So there's 10 slots. And okay, let's figure out. So they can be arranged here. Oh yeah, so Hugo and Leo. Hugo and Leo, and okay. So there's, would I right in saying, just picking their ways, they can be here, in these two, in these two, in these two, in these two, yeah?
Yep.
And they can go the other way around then, Hugo, Leo, Leo, Hugo. So that's 5 different slots, but they can be arranged each different way, so that's 10. Number of ways this students can maybe arrange, but once you've done those, these other 8 slots can be put anyway then, can't they?
Oh, right.
So that's going to have to be times by 8 factorial. So the other students can be put anywhere. So you've got these 10 different spots that these guys can land in, and then everybody else is just random order, doesn't matter, 8 factorial. That'd be 403,200 ways, which I think you're way short of.
Yes.
Okay. What was your answer? 5 factorial times 2? No. Can't remember what your answer was. What was your thinking here, or is it just you totally agree with me now? No. Okay.
I was thinking that there's 5 of them, but then that doesn't make sense. What I was thinking, yeah.
Okay, so I presume if you got that wrong, maybe you can have a little think about this second answer and work something out now. So the second question is, find the number of ways students may be arranged if Hugo and Leo may not sit next to each other in the same row this time. So that means this doesn't matter anymore. They just can't sit beside each other in the same row. So perhaps have a little go with that one.
Okay.
See, can you come up with an answer before I do it? So H and Leo together like that is not an option, not allowed.
I got an answer. It feels like it could be right.
Hmm.
Well, the method feels like it could be right anyway.
Tamara, any luck?
I'm just confused.
Confused. Okay. All right. Let's hear your answer. So, Sean.
Okay, so 10 factorial to start off with, because that's how many ways total,
Okay.
and then minus.
Yeah.
8 times 2, because there's 2 of them, and there's 8 different places where you could put 2 of them in.
Okay.
Times.
Yeah, that makes sense. Let's just slow this down a little bit, Kit. All right. So yeah, there's in this row they can sit in these 2 slots, these 2 slots, these 2 slots, or these 2 slots. That's 1, 2, 3, 4 ways, and there's second row, of course. That's 8 ways they can sit, and then they can be Leo, Hugo, or Hugo, Leo. So that's your 8. 2. Yep.
And then times 8 factorial, because that's how all the other students can sit. And then is that it?
That's it.
Okay.
Yeah. So once you've chosen those 2 slots, all the rest of them will be in 8 factorial different ways. So if you just think about that, if you have them where they are here, they can be like this, and then you can have any 8 here, any 7 here, then any 6, 5, 4, 3, 2, 1. And then that can also be the other way around, Leo, Hugo, and have the same 8 factorial. And that's why it's twice in these 8 slots.
Yeah.
Is that making sense, Tamara?
Yes.
Yeah. Okay. It's you would probably need to do maybe question 2. I'm going to get to question 3 in a second, but question 2 and 4 and 5 blind again, and see do you get the right answers again, and just think it all. Leave it a week and then do it again and see can you remember how it all works. So maybe try that in a week or so. Maybe I'll surprise you in a week and see can you do.
Okay.
Right, the best kind of maths. Okay, so we have question 3 now, which was one we've done before. I actually think the video of this is on YouTube already. I don't know if but we'll do it again. And I think the first part is the hard part.
Yeah. This is only 6 points, so it shouldn't be any harder than 2 or 4. Not that those are easy.
Yeah, it should be not harder. All right, well, yeah. So let's look at the game anyway. I, B, X, L, C. This is our game. And then the other person then match or not match. I can't remember what it is. So somebody wins. You want Sophie to win, and Sophie wins only when
There's no matches.
Okay, so we're going to find out all the times that there is matches.
Yes.
All right. So let's go through. So you have you can or create a little table. So 1 match, 2 match, 3 match, 4 matches, 5 matches. That's the number of matches. And we're going to find out each of those possibilities and then add them together. All right. First of all, how many possible ways would there be of the 5 cards coming out?
It's going to be 5 factorial.
Okay, so we have 5 factorial as our start point. And when we get all these ways, and we're going to subtract them, aren't we?
Yes.
Okay, so how many 1 matches?
There could be 5 different 1 matches. And for each of those 1 matches, there's 4 factorial different ways of doing it, right?
And this is where you're wrong.
Ah.
So 5, okay, so for 1 match, you have 5 cards, and one of them is going to match.
Yes.
But then you've got to actually look at what that means for the other cards.
Oh, right. It can't be 4 factorial because they might also match in that case.
Yes. So let's say first one does match. Then many options are here for this card, and it cannot be V. Only 3 options. Cannot be V. Now, how many options for X? Presuming we've selected one here.
then it's. But the one chosen for V could have been X, in which case there would.
So it also could be 3.
Uh-huh.
But then there's only 2 cards left. And neither of them can match.
That means only one?
Yes. Let's think about that again. If we have I gone, how many options can there be here? Anything but V is all we're allowed. So we're allowed X, L, and C.
Mm-hmm.
Right. Anything but X here. So we're allowed V, L, and C.
Yeah.
But here, it has to be the other one. It cannot be L. It has to be the other one that's left, presuming that it hasn't been chosen. So it's C and then L, something like that. So multiplied by 9, 3 times 3.
Okay.
All right, well, let's look at one when we have 2 of them gone. So let's just do them above here. So 2 gone. What's our option? So let's say I and V are gone as our 2. You can pick any 2, obviously. Many options here for this one.
Then there's 2 of them are gone. There's 3 left. That means there's only 2 that they could be.
Yeah, 2 allowed. Otherwise, it's going to clash. And then finish off at 1 and 1. Same as before.
Okay.
Has to be the other one for it to work. So these we're trying to find. Let's remind ourselves what we're trying to find. We're trying to find the times where exactly these 2 matches. So therefore, after that, it cannot be the letter that it is above.
Yeah.
Okay. And if this is a little bit confusing, if this V, L, and C are 3 options because V couldn't have been chosen there because V was the one. Does that make sense? So these 2 are both 3. Okay, so that would be 5, choose 2, and that would be 2 times 1 times 1, which is 2. After that, then, what about the next one? I think that's 45, and 5 choose 2, 10 times 2, so that's 20. What about 5 choose? Well, 5 choose 3. Don't want to do this out again. Just put them down here. So if we've 3 of them gone, I, V, and X, for example, what's our option?
1 for each of those.
Yeah, 1 and 1. So that's times 1. So that's going to be just 5 choose 3, which is also 10.
Yeah.
What about for 4?
You can't only have 4 matching.
No, because then 5 would match. You're right.
Yeah.
So a big fat 0. Can't work.
And then 5 matching, there's only 1.
Yeah, 5 choose 5, which is times 1. So that's 1. So adding up all these together, 6 and 76. So 5 factorial is 120. Take away that 76 gives 44. 44 ways out of that 120 then is our probability, which can be simplified down, divided by 4, and 11 over 30. Was it a show of that? Yes, it was. 11.
Okay.
Yeah, now that was, I think that was the hardest one.
Yeah.
When I did that, I got it wrong about 3 times. It took me a while to figure out. I did have to draw it out like that and just go through each one. Yeah. What did you guys get for the answer there? You probably got the same answer as I got the first time around.
I didn't even get an answer. I was trying to figure out how I could figure it out with the... Because like I was trying to do it like that, where I did 1 and then all the other ones, but I couldn't... I didn't realize that... like, okay, so I... That's there, and then how many can be V? That's... But I was... how many could be V? There could be 3 for V, but then I wasn't sure how to do it for X, because X could have been chosen, or it might not have been chosen. But then you just put 3, so that makes sense.
Yeah. Okay, well, yeah, this was the most difficult question, without a shadow of a doubt. And then to finish it off with mean and variance, when you're thinking of combinations is the mix-in probability was a bit mean, but to get the actual last part,
I think the last part was okay. That's just a binomial distribution. I like this.
yeah, especially the first part. The first part is determine the mean. So for 2 marks, determine the mean, knowing the probability of winning is just the number of trials. So there was 90 trials, and what's the probability of winning each time? It was 11 over 30, isn't it?
Yeah.
So that would give you the mean. So the number, or if you want to use proper algebraic or probability terminology, the expected value is the number of trials times the probability. But this just makes sense anyway. So it'll just be 33 wins.
Yes.
Is the mean. The variance then, you should have been able to do this because they gave you the probability. Did you get the variance?
20.9, right?
Yeah. So the variance is a formula in our formula booklet. This is the formula. So you just
Why did I ask for variance and not standard deviation though? Because isn't standard deviation the useful one?
Yeah. Well, there you go. Variance is the one that's used in statistics. Because you don't need to get square roots, and it's very difficult to deal with square roots in some statistical analysis. You have to deal with variance. So, especially when you're dealing with unknowns. So this is why variance is used a lot.
Okay.
You just have to determine. For us, it's simply just getting the square root afterwards. But when it gets more complicated, it's not. N times p. So we know n, we know p, we know 1. So you just put all that in.
We know 1.
We do know 1.
I'm not sure, sir. That's not in our formula booklet.
I know. Well, it's on your calculator, so that's fine. Okay, and this 20.9 when that works out. So the second 2 parts, perhaps revisit some probability for that, but we're not doing that now. The first part was rock hard, very difficult.
Yeah.
Okay, so that's combinations. Now you can look at chapter. Which chapter is it from? Chapter 7. Do put in if you figure see there's not much. You didn't have anything really for binomial beyond that. I still haven't done the ones in the first section. Oops. I don't want to do that one, Sean, the perfect square one. But I just don't like it. I presume the other one just is. Do you have that open beside you, the other ones?
I do have it open, yeah. It does look like the other one would be easy enough. Just put this one, and then you find out.
Yeah, what did you get?
I haven't actually done it, but
I
just put it there because I remember doing a question like that before and getting it wrong. Yeah. But then it worked when I started from the middle term instead of the first one.
I started this the other day, but I didn't finish this. When I say started, I wrote the question. So I will do that one. 26, I'll have a look at. I'm not loving it in general. Maybe I'll get inspired. Okay, you've no extra questions for the logs and exponents, so that seems to be okay. Binomial expansion, I did that extra 1 for you. And if you find anything in this chapter 7 from book 2, pop it in there, maybe 1 or 2 questions, and have a look at it, because we may need some more work on this, but there's not a whole pile of other questions. Complex numbers, I've started to put those questions in, which you may have seen. I'm going to put 1 more in, and you're welcome to add additional questions. So I'm taking it. Oh, Tamara's gone, is she?
Is she? Oh, she has.
Okay. She has. I'm taking it that tomorrow you're not going to be in. We have a lesson, you know that?
Yes.
Yeah, okay. So we'll try and get through those complex numbers, presuming that you have time to do them over the next 24 hours. All right, Sean, I'll leave you go start those complex numbers. I'll fill in 1 more. And
wait. Sorry, we have a lesson tomorrow?
Yes.
When?
1:35. Now, if you can't make it, that's okay.
1:35. That's okay.
Okay. Yeah. So that's a lesson tomorrow. Tomorrow's just disappeared. Okay, Sean, I'll leave you go, and I'll put that in Manage Back as homework for tomorrow.
Okay. I'm gonna try to see if I can do the question 2 and 4 again now.
Yeah, do, yeah. Maybe I would actually, yeah, you could probably do them straight away now. I'd give it a week.
Mm-hmm.
I wouldn't do them now. But that's up to you.
Okay.
Okay. All right. See you, Sean.
See you, sir. Thank you.